Okay, organic chemistry 2330. We're going to continue on with chapter 2 and look at a specific reaction that uses the carbonyl functionality, specifically in aldehydes and ketones. And this takes advantage of the fact that we have that partially positive section on carbon and partially negative section on oxygen. Okay, so when we're talking about these reactions, what we can do is we can use a nucleophile or something that wants to be attracted to a positive charge to create a new bond with that partially positive carbon of the carbonyl to create a new tetrahedral addition intermediate. Okay, so this can undergo this attack and create that material that we can then go on and do additional reactions on or do a substitution reaction. But let's first talk about the addition reaction here, okay? So when we do an addition of carbon nucleophiles to the carbonyl, we end up with a new carbon-carbon bond. And so that we can actually use this to help build bigger and bigger organic molecules. So the first one I want to talk about is what's called Grignard reagents. And in Grignard reagents, we take an alkyl halide, react it with magnesium, and when we do this, we create a carbon with a negative charge on it. And that becomes our nucleophile. Okay, so like I said before, we take an alkyl halide, we actually take metallic magnesium in a solvent like ether, one that doesn't react with the system, and then create this intermediate compound here called the magnesium bromide salt of the alkyl group. And if we look at that bond very carefully, we can see that it's a very polarized bond between the carbon and the magnesium. And so we can actually think about this as the carbon having a negative charge on it and the magnesium maintaining its positive charge on here. Okay, we can make these Grignard reagents out of aromatics, aliphatics, and vinyl groups. And so we can make a wide variety of different Grignard reagents to make a wide variety of different new compounds associated with it. So now that we can make this Grignard reagent, and now that we know it has that anion on it and it wants to attack the carbonyl, let's see how it actually works, okay? So once we form this, Grignard reagent here, it actually has an issue because it is so strong as a negative charge that it is more basic than most of the solvents we have, meaning that we cannot have a Grignard reagent in the presence of a water, an alcohol, a phenol, a carboxylic acid, an amine, a thiol, or even an alkyne. Imagine anything that can hydrogen bond will react with this Grignard reagent, meaning we have to make sure that whatever solvents we use, we cannot have anything that looks like an acidic proton. Now notice alkynes here they have a pKa of 25, so this is strong enough to remove the proton from an alkyne even. So this is a very, very strong base, and so we want to make sure that we don't have any of these materials in our solutions. That's why we typically use ethers in this reaction. Okay, so now that we have this very strong nucleophile, this very strong anion, what's going to happen? Well, the first thing it's going to do is the electrons that are in between the carbon and the magnesium are going to attack the carbonyl compound that's partially positive. And when it does this, it creates this new center that is tetrahedral, and then it has a negative charge goes on to the oxygen. So now the oxygen has a salt with magnesium bromide. Right here. When we finish the reaction, what we do is we usually quench it in water and acid, and that will yield our final product as an alcohol. If we have an alcohol, we always form a primary, if we have an aldehyde, we always form a primary alcohol, okay? Because there's two hydrogens on that, there's at least a hydrogen on that aldehyde, and we convert it to an primary alcohol. Okay. If we have a substituted aldehyde here, we can make it into a secondary alcohol because we have the one carbon group from what was on the aldehyde, and then we're adding a second carbon group to the carbonyl, and we'll yield a secondary alcohol. Okay. So if formaldehyde yields a primary alcohol and an aldehyde yields a secondary alcohol, that means that if we use ketone, we're going to get a tertiary alcohol. because there's already 2 carbon groups on the carbonyl because it's a ketone, and then we're adding a 3rd carbon group to that carbonyl carbon to give us that tertiary alcohol. So using the Grignard reagents, we can make a primary alcohol with formaldehyde, a secondary alcohol with a substituted aldehyde, and a tertiary alcohol with a ketone.